They are repeated, one slightly to the top right hand side of the other. Join the bottom with another straight line. Join the top with a straight line. Now this doesn't look like a cylinder because we haven't started dotting what shouldn't be seen yet. So you have to visualize, oh actually this part is hidden from view. Okay, so this is our cylinder. Our eye is over here looking at our cylinder. Okay, and now we need the dimensions of this container. Dimensions refer to the length, the breadth, the height, so on and so forth. So you can take reference from one piece of cookie over here. Okay, the radius is 3 cm. Remember, we are doing the repeat. We are repeating the same cookie over and over again. So when we get the entire packet of cookie, it should still have the same dimension. In this case, it is a circle. So the radius has still to be 3 cm. That is one of the dimensions that we need. Now the other dimension will be the length. What is this distance over here? How much? 30. How much? 40, right? Because one piece is 2 cm thick. I've got 20 pieces stacked together with no gaps. This has to be 2 times 20 equals to 40 cm. One piece is 2, I've got 20 pieces. So this is my dimension. Can you try part B? Cuboid over here, you can start with a square. Then draw another square. The same square, the same corner to the same corner. From here to here, same corner, join, same corner, join. Then join the last corner with dotted line because you're not supposed to be able to see it. Okay, then the last square at the back, there are 2 lines that should be dotted because they shouldn't be seen also. So take an eraser, just dot them. Okay, done. So this is our cuboid, but we have not included the dimensions yet. So since one piece of it is 4 by 4 cm, that is what you need to do. Show that this is 4 cm, this is also 4 cm, and since the thickness is 2 cm, when we stack them all up, we have 20 pieces of 2 cm. 20 times 2, and this will be 40 cm. Okay, let's do one last one, part C by yourself first. Okay, so here we have the triangular prism for each cookie. Well, it's a ridiculously thick cookie. Can you imagine a thick cookie that's 3 cm thick? How to eat? So thick. And over here we've got, again, 20 pieces. To draw one triangle, okay, not satisfied, draw again. Repeat the same triangle. Join the same corners. This is hidden, so we dot it. And we erase what else? What others that shouldn't be seen. Okay, so this is the prism. After you stack 20 pieces together. So next, put on the dimension, just follow. This is the same 3 cm, the same 2 cm, same 3 cm, and now instead of just 3 cm, we've got 20 pieces. 20 pieces of 3 cm has to be 20 times 3. Okay, now back to this. The following diagram shows 3 ways of packing 20 biscuits. 3 different ways in a closed container such that there's no empty space. Okay, so the first way is in container A. You put it side by side, 4 pieces side by side, then you stack them up. Okay, that's one way. The other way, in container B, you just repeat them all the way. In container C, you put 2 of them side by side, and then you repeat the same process. Okay, now they tell us that each biscuit actually looks like this. It is a square, or rather it is a cuboid with a thickness of 2. So this is kind of like a biscuit. Find the cost of making each container. Okay, to make a container, you have to visualize the box that is used. For each of these boxes, the box will cover the outside. Only the outside. We're not going to wrap individual biscuit pieces. It's going to be a box for the outside only. So we're going to get 3 different shapes of boxes. And now they tell you that the material to make the container, for every 0.01 square meters, this is an area. For every 0.01 square meters, it costs 5 cents. Not too expensive. It's probably just paper or cardboard. If you are a manufacturer, which container will you choose? Great. Let's pretend that we are all manufacturers now. What is going to help us decide which way to pack? Same 20 cookies in 3 different ways. 20 biscuits, sorry. In 3 different ways of packing. What is going to help you decide how you want to pack them? Given that material to make the container costs 5 cents per 0.01 square meters. Do you want to spend a lot of money on the packaging, or do you want to spend as little as possible? Let's spend as little as possible, right? So we want the packing method to result in the smallest area required. And then for the box, if I pack it this way, this is an example of container B. If I were to pack it this way, I need a covering over here, 2, 3 at the bottom, 4 at the sides already, 5 and 6. These are the 6 bases that I require. And I need to calculate what is the total area. Now if it is in the form of container A, I'm going to have to stack them 4 together. Okay, looking like this, 4 of them. So this area, the total area will be 1, and then the other side 2, 1 over here 3, 4, 5, 6. I will need to calculate these 6. And the final configuration, C. C looks like this. Okay, C looks this way. Okay, same 1, 2, 3, 4, 5, 6. There are still 6 of them. And we need to calculate all the different areas. It can get a little tedious, right? Because for each container we got 6 faces. Really must calculate so many. Here's no need, there's a shortcut. The shortcut is still using the same idea of repeated squares. If I want the surface area of one of these squares, we're going to be looking at the front and the back, right? So the front is just length times breadth. If it is 4 cm by 4 cm, or in this case it is 6 by 6. 6 times 6, 36. On the other side, also 36, isn't it? So it is times 2. then I need to consider the thickness over here, right? Okay. If I know that this is 36 already, after I stack so many of them, it is still the same 36 here. It is still the same 36 over here. So the front and back is very easy to calculate. Just calculate area times 2, that's it. Now the issue is the sides. There are 4 sides. What you can do is length times breadth. Length times breadth, length times breadth. Then you need to add 4 times. Alright? Length times breadth 4 times, you need to add that. In order to get the 4 sides. But there is a shortcut. The shortcut is for the same square. You find the perimeter. This is 6, 6, 6, 6. Then you multiply by the length. One calculation. 6 plus 6 plus 6 plus 6 is 24. Then you multiply by the length. I think you have the answer already. You don't have to add this to this to this to this. That is the shortcut. Okay? So now I'm going to demonstrate for you. Okay, I'm going to make things easier, I'll just do it at the side over here. So that you don't have to keep flipping. Now, total area. I always like to tackle the cross-sectional area first. So can you shade the cross-sectional area with me? It's here. Okay, this is one possible cross-sectional area. This is the shape that is repeated from top down. Okay, so total area equals to that cross-sectional area times 2. One on top and one below. Okay, if I have 4 squares placed together, what is the resulting shape? 4 squares placed together. Still a square lah, right? So what is the area of this square? If one little square has side of 6 cm, I'm sure you can do it. There are a few ways you can do it also. Maybe you want to find the area of one square, then you times 4. Maybe you want to find the distance of this big square, then you multiply it by itself. It will give you the same answer. Okay? So here I know that this is 12 cm in length. So the total area will be 12 square. Okay, this is the area for one cross-sectional area, the one on top. But how many of these are there? There are always 2. One on top, one below. The one below is hidden, you cannot see it. So you multiply this by 2. Okay, so now I have the area for the top and the bottom, represented by blue color. Now, I'm going to calculate the area for the sides. Okay, so the one way is find this distance. The distance is 12. So I plus 12 multiplied by this height over here. So if one piece is 2 cm, plus 2, plus 2, plus 2, plus 2, 1, 2, 3, 4, 5. This is a total of 10 cm, right? 12 times 10. This in red gives me this area. Okay so far? Then I have to do the same for the other 1, 2, 3 sides. Can you imagine what the steps are going to be like? For the next addition, this is what I'm going to have. Over here, let's focus on this length. This is again 12 plus another 12 times all the same height, 10. So now I've completed 2 faces already. 2 more faces to go. And it is a repeat, isn't it? Because our cross-sectional area is a square. So moving on to the back that is hidden from us, it is another 12 times 10. And on the left hand side, that is another 12 times 10. You see all this repeated working over here, it is always multiplied by 10, multiplied by 10, multiplied by 10, multiplied by 10. The reason is because we are stacking them up this way, and this vertical distance is 10. So this repeated multiplication by 10 can be simplified. How do we simplify that? How do we shorten it? This 12. The first 12 is over at the front. Remember, that's the first one that we started off with. This particular 12. Then the next 12 came from here. The next 12 at the back. And the next 12. What I've just outlined is actually the perimeter. It is the perimeter. 12 plus 12 plus 12 plus 12 plus 12, 4 times. So if we continue with this working, we can calculate it out. 12 square times 2 plus, and we get a total of 768 square centimeters. This is the total area for container A. 768 square centimeters. The shortcut is for the same container A, total area. The first part is the same, 12 square times 2, because the top and bottom doesn't change. Then I add the perimeter. The perimeter, the green color portion, 12 plus 12 plus 12 plus 12, or you can just say 12 times 4. Okay? This is the perimeter. Then I multiply it by 10. It is a little faster than adding all of them up separately. And we will still get the same answer, 768 square centimeters. Okay? All this is for container A. My recommendation to you, choose this method, so that there is less for you to press in your calculator. And it's going to give you the same thing anyway. So the less you have to use your calculator, the lower your chances of any other mistakes. Okay, so I'll just remove this. And keep what I recommend to you. Please don't be upset that you actually copied the first one, because that is the basis to how we got the easier shortcut. It is only because we had the first step where we looked at all of them separately, then we can simplify it, factorize it, to get an easier solution method. Okay, please work with me over here. Everybody look at the screen or lectures. Write down, this is for the cross-sectional area. It is always the cross-sectional area times 2, because it is repeated top and bottom, front and back, always repeated. This portion is known as the perimeter or cross-section area. You can call this a formula if you like. It will always work. Then this 10 over here is known as the thickness. So by writing this down when you revise, it should be easier for you. Okay, so now in container B, we're going to use the same formula. But you notice that in the formula, there is a repeated phrase. It is known as the cross-sectional area. Cross-sectional area. So we need to identify where the cross-sectional area is. The cross-sectional area is the one that is repeating itself all the time. So in container B, okay, please highlight this as the cross-sectional area. This is the part that is repeating. And while we are at it, Can you identify where is the cross-sectional area for container C? This will be our cross-sectional area, okay? So in order to use this formula, we must identify where the cross-sectional areas are. Okay, so for container B, total area equals to, according to our formula, cross-sectional area. So in this case, cross-sectional area will be 6 squared, 6 times 6. Then I need to multiply it by 2 because there is 1 in front and 1 at the back. Multiply this by 2. Plus, the next thing I need is the perimeter of the cross-sectional area. Perimeter. Perimeter is over here. 1, 2, 3, 4 sides. You can call it 6 plus 6 plus 6 plus 6, or you can call it 4 times 6. Whichever you like. Okay? So 6 plus 6 plus 6 plus 6. This is my perimeter. And I need to multiply this by the thickness. The thickness goes here. If one piece is 2 cm thick, I've got 20 biscuits. 20 times of 2 cm. 20 times of 2 cm. And here is my surface area. One 1032 square centimeters. If you have to choose, will you choose option container A or container B? Of course you choose A. Yes, less material, right? Less material means it's cheaper. Okay? Now, but we have a last container that is C. Without doing any calculations, right? Can you guess whether C is going to be cheaper or is A going to be cheaper? Without doing any calculation. Just based on your own real-world understanding of how things work, your own logic. Is A going to have a smaller area or is C going to have a smaller area? Who thinks it's going to be A? Come on, be more confident of yourself. Okay, yes. How about C? Who thinks C is going to be less area? So one way we can actually decide is to compare A and B. The difference between A and B is that the cross-sectional area for A is much bigger than the cross-sectional area for B. Because we stack 4 of them, we place 4 of them side by side. With this difference, we resulted in a reduction of the area, total area. So comparing A and C, if A has a bigger cross-sectional area, it should mean that it has a smaller area compared to C. Let's confirm that. So in the part C, container C, total area, same thing, we need the cross-sectional area. Okay, we have already highlighted it. The cross-sectional area, this time it is not a square, it is a rectangle. It is 6 times, this distance over here is 12. 6 times 12. So there is no square over here. There isn't a 6 square or 12 square. It is just 6 times 12. That is the area of this rectangle. But there are 2 of them. 1 in front and 1 behind. And now, I need to add the perimeter of the cross-sectional area. We have already highlighted the cross-sectional area. So this is my perimeter. 6 plus 12 plus 6 plus 12. 6, 12, 6, 12. Finally, we need to multiply this by the thickness. One piece over here, 2 centimeters thick. How many do I have altogether? 10. Okay, you can go and count all of them, or you can take 20 biscuits divided by 2 in front, so we have 10 of them stacked up. So there are 10 biscuits multiplied by 2 cm. 10 times 2. So this is our thickness. Okay, so there we have it, the three different lengths, the three different areas. But that is not what a final question. Did I ask for the amount, the cost? Find the cost of making each container. So now that I have the area for all of them, I have to find out how much it costs. This is in square meters, 0.01 square meters. But my area over here is in square centimeters. So I have to convert them from square centimeters to square meters before I can find out the amount of money required. Okay, so I think it was yesterday or the day before we went through the conversion. How do you convert from area in square centimeters to square meters? This was yesterday. Divide by how much? Is it just divide by 100? 100 square. Because if you divide by 100, you're talking about length. But here we're talking about area. So we need to divide by 100 and we square it. So 768 over 100 square. Our answer is 0.0768 square meters. So same over here, 1032 over 100 square. 100 square is 10,000, huh? So 4 zeros. Last one. Okay, so this is the conversion. Please, when you're doing your own conversion, you have to see whether they make sense or not. Earlier, we said that container A has the smallest area. Now, after you do the conversion, A must still be the smallest value. If for some reason you convert already, then C has the smallest value, then you know something is wrong. Okay, we're now going to make use of these three areas to find out the corresponding cost for making the container. So now I need more space. For part A, container A area is 0.0768 square meters. Container B area is 0.1032, C 0.0864 square meters. Okay, so here I've written down all the areas and now I'm ready to find out the cost. For 0.01 square meter, it costs 5 cents. Now I have for container A 0.0768 square meters. It is direct proportion for cost for A. Okay, so we've got 0.01 square meter costs $0.05. If I need 0.0768, I take $0.05, which is 5 cents. I divide by 0.01, then I multiply by 0.0768. Remember earlier in the year, we did many questions like this, direct proportion. Whatever is on the right, divide by whatever is on the left, and we multiply by whatever we need to find. So the cost will be 0.05 divide by 0.01, then we multiply by the required area, 0.0768. 0.05 divided by 0.01 is 5. So So this is our cost for A. So do the same for B and for C. Use the next 2 minutes to just quickly practice your calculator skills. The cost for A, B, and C are shown over here. Do you get the same values? If you did, then based on this, we can answer part B. Because part B says if you are a manufacturer, which one will you choose? So answer will be, I will choose A. If they ask you to state a reason, what will your reason be? It's the cheapest. Yeah, that's it. Okay, now in question 3, which you will do by yourself, I will give you a hint. This time, instead of square biscuits, they have cookies, which are modeled after this cylinder. 6 cm in diameter. This is the diameter. If you want to find the radius, you just divide it by 2. I don't know whether you need it or not. Next, it has a thickness of 3 cm. So they're going to pack it in a similar fashion. In box A, just stack all of them. In box B, side by side, stack. Box C, 4 of them side by side and stack. Find the cost of manufacturing for the box. Okay, so again, 0.0 now it's 20 cents per 0.101 square meters, which means I need to find the area for all of them again. The area is given by cross-sectional area. You can start highlighting the cross-sectional area with me now. This is the cross-sectional area. This cross-sectional area, the square, the entire square, because the box has a square face, it's a cuboid. This square is repeated at the back over here actually. That's why it multiplied by 2. Okay, now in box B, this is the cross-sectional area that we have. And again, multiply by 2. And for box C, this is the cross-sectional area that we have. The formula for the cross-sectional area is, in this case, if it is a square, length and breadth. Box B is a rectangle, length and breadth. Box C is a square, length and breadth again. The question is, what's the length? What's the breadth? So over here, we know that this is 6 cm. What about the height over here? Knowing that it is a circle, if it is a circle, no matter how I turn it, the diameter has to be the same. So this is actually 6 cm also. Okay, now we have the dimensions for the first box, for the front. What about for the second box? What is this total distance? And what is this total distance? Finally, for box C, what is the total distance here and the total distance here? So based on this, we will be able to get a cross-sectional area. Then you need to multiply by 2. Next part is finding the perimeter. Perimeter of the cross-sectional area, I think you can do that. After you find the perimeter, we need to multiply it by the thickness. The thickness is shown here. What exactly is this thickness? And they gave you another clue. They tell you that we've got 20 cookies, 10 cookies, and 5 cookies respectively. And then we know the thickness of each cookie. So I think you can find out and calculate for yourself what the actual thickness is for each of these containers. Find out the area, find out the cost, and make a decision. Okay, this is your homework for today.